Ladies and gentlemen, this is not just a story about building cars, it's a story about rewriting the rules of global manufacturing. Why would a company known for defying convention choose a location that most people underestimated? The answer isn't politics and it isn't cheap labor. It's about speed, scale, and survival in a world racing toward electrification. In the next few moments, you'll see how one decision reshapes supply chains, collapses costs, accelerates innovation, and brings the future closer than anyone expected. Stay with me because what happens next changes how the world builds technology. And the decision to choose Mexico reflects a disciplined engineering-first approach to scaling sustainable manufacturing, while staying relentlessly focused on efficiency, resilience, and long-term impact. At its core, this move is about building the future closer to where it is needed, reducing friction across the entire value chain, and accelerating the mission to make advanced electric vehicles accessible to more people around the world. And Mexico offers a uniquely strategic manufacturing environment. Its proximity to North America enables tighter integration with existing production, supply, and distribution networks. Shorter logistics routes mean lower transportation costs, reduced emissions, and faster response times. Every kilometer saved in the supply chain compounds into measurable gains in efficiency, sustainability, and operational agility. This is not just about geography, it is about designing a system where every part works smarter together. And equally important is Mexico's deep and growing industrial ecosystem. Decades of experience in automotive and advanced manufacturing have created a skilled workforce capable of operating at the precision and scale required for next-generation production. Engineers, technicians, and operators in the region are already fluent in high-volume, high-quality manufacturing standards. This allows rapid ramp-up while maintaining the exacting quality benchmarks that define the brand's products. And cost efficiency plays a role, but not in a simplistic way. The objective is not lower costs for its own sake, but higher value per unit of energy, material, and labor invested. Competitive labor costs combined with strong technical capabilities allow more resources to be directed into innovation, automation, and continuous improvement. The result is a factory designed to be more advanced, more flexible, and more productive than traditional plants. And trade and policy alignment also factor into the decision. Mexico's integration with North American trade frameworks enables vehicles and components to move efficiently across borders, supporting regional markets without unnecessary barriers. This creates stability in planning and investment, allowing long-term commitments to infrastructure, technology, and people. Predictability at this scale is essential when designing factories meant to operate and evolve for decades. And energy and sustainability considerations are embedded from the start. Mexico presents opportunities to integrate renewable energy sources into manufacturing operations, supporting lower carbon production at scale. Building facilities designed around efficiency, electrification, and smart energy management reinforces the principle that sustainable products should be made in sustainable ways. Manufacturing is treated not as a necessary cost but as a platform for innovation in its own right. And the choice of Mexico also reflects a belief in regional growth and shared progress. Large-scale manufacturing investment creates high-quality jobs, develops technical talent, and strengthens local supplier networks. Over time, this builds an ecosystem where innovation accelerates, naturally driven by collaboration between manufacturers, suppliers, and educational institutions. Strong ecosystems reduce risk, increase speed, and improve outcomes across the board. And from a systems perspective, expanding manufacturing into Mexico diversifies production capacity and increases resilience. A distributed manufacturing footprint reduces exposure to localized disruptions and enables more balanced global output. Flexibility at scale is essential as demand grows and markets evolve. Factories are designed not as static assets, but as adaptive systems that can incorporate new technologies, processes, and products over time. And ultimately, choosing Mexico is about designing the most efficient path to scale sustainable transportation. It aligns talent, infrastructure, energy, logistics, and policy into a single coherent manufacturing strategy. Every decision is evaluated through the lens of impact, per unit of effort, speed of execution, and long-term sustainability. This approach allows advanced technology to move faster from concept to production and from production to the hands of people who use it every day. And this manufacturing strategy is also shaped by speed of execution. Building at scale demands environments where permitting, construction, and infrastructure development can move in parallel, rather than in sequence. Mexico provides the ability to move fast without compromising standards, enabling factories to be designed, built, and optimized in compressed timelines. Speed here is not about rushing. It is about eliminating unnecessary delays so learning cycles can begin earlier and improve faster. And automation plays a central role in this expansion. New facilities are conceived as software-defined factories where machines, robotics, and data systems are tightly integrated from day one. Mexico's manufacturing base is increasingly aligned with advanced automation, making it possible to deploy high-density production lines that reduce waste, improve consistency, and scale output efficiently. The factory itself becomes a product continuously refined through data and iteration. And supply chain localization further strengthens this model. Establishing production in Mexico encourages suppliers to co-locate, shortening lead times and increasing transparency across materials, components, and subsystems. When suppliers operate closer to the factory, feedback loops tighten. Design changes move faster, quality issues are resolved earlier, and innovation spreads more efficiently across the network. This proximity turns the supply chain from a linear pipeline into a collaborative system. And there is also a long-term workforce vision embedded in this decision. Advanced manufacturing requires more than labor. It requires problem solvers who understand systems, processes, and continuous improvement. Investment in training, technical education, and on-the-job learning transforms factories into centers of skill development. Over time, this creates teams capable not only of running existing processes but of improving and reinventing them. And the physical location supports future scalability. Sites are selected with expansion in mind, allowing production capacity to grow without disrupting ongoing operations. Layouts are designed to accommodate new vehicle platforms, energy products, and manufacturing techniques. This flexibility ensures that factories remain relevant as technology evolves rather than becoming constrained by legacy design decisions. And transportation efficiency extends beyond finished vehicles. Raw materials, subassemblies, and energy inputs are all optimized through proximity and infrastructure. Railroad and port access reduce dependency on long-haul transport and buffer against global shipping volatility. Lower logistics complexity translates directly into higher reliability and more predictable output, which is critical at high volume. And manufacturing in Mexico also supports faster market feedback. Vehicles produced closer to key markets reach customers sooner, allowing real-world data to inform design and software updates more rapidly. This shortens the distance between engineering decisions and customer experience. Faster feedback leads to better products, and better products reinforce demand, creating a virtuous cycle of improvement. And regulatory alignment is approached pragmatically. Compliance is built into design rather than added later, reducing friction as production scales. Facilities are engineered to meet or exceed safety, environmental, and quality standards from the outset. This proactive approach minimizes rework, lowers long-term costs, and ensures consistency across global operations. And another critical factor is risk distribution. Concentrating all production in a single geography increases vulnerability to disruptions. Expanding into Mexico balances capacity across regions, improving continuity and stability. Resilience at scale is not achieved through redundancy alone, but through intelligent distribution and adaptability. And the broader vision is about transforming how manufacturing is done. Each new facility is an opportunity to rethink assumptions, eliminate inefficiencies, and push boundaries. Lessons learned in one location are rapidly transferred to others, accelerating improvement across the entire network. Mexico becomes not just a production site, but a contributor to global manufacturing innovation. And every aspect of this decision is guided by first principles. Materials are evaluated by performance per cost, processes by output per unit of energy, and locations by their ability to support long-term mission alignment. The result is a manufacturing strategy that is leaner, faster, and more sustainable, designed to scale without losing focus on quality, efficiency, and impact. And as production volume increases, continuous optimization becomes the dominant principle. Factories are treated as living systems, constantly measured, analyzed, and refined. Data from every stage of production informs real-time adjustments, reducing defects, improving throughput, and lowering energy consumption. Mexico's growing base of digitally literate engineers and technicians supports this data-driven approach, allowing rapid iteration without disrupting output. And material flow inside the factory is designed to be as efficient as the vehicles themselves. Shorter internal transport paths, simplified assembly sequences, and modular production cells reduce complexity. These design choices are easier to implement when facilities are built from the ground up without legacy constraints. The result is higher density manufacturing, where more value is created per square meter of factory space. And energy management is integrated at the system level. Manufacturing equipment, climate control, and logistics operations are optimized to work together, rather than independently. Opportunities to pair production with on-site energy storage and renewable generation are evaluated from the earliest design stages. This reduces peak demand, stabilizes energy costs, and demonstrates that large-scale manufacturing can coexist with responsible energy use. And the decision also strengthens vertical integration. Proximity enables tighter control over critical processes that define performance, safety, and reliability. By bringing more steps in-house or closer to the factory, variability is reduced and innovation cycles accelerate. Vertical integration is not about control for its own sake, but about ensuring that core technologies evolve quickly and cohesively. And from a product standpoint, localized manufacturing supports platform flexibility. Vehicles are designed around shared architectures that can be adapted to different markets with minimal changes. This modularity simplifies production, while allowing regional customization where it adds real value. Mexico-based facilities can support multiple platforms, adjusting output mix as demand shifts. And quality is approached as a built-in attribute, rather than a checkpoint at the end of the line. Processes are designed to prevent errors, not just detect them. Automation sensors and software continuously monitor critical parameters, enabling immediate correction. This philosophy reduces rework, increases consistency, and improves long-term durability of the product. And there is also a strategic emphasis on supplier development. Working closely with regional partners raises overall capability across the ecosystem. Shared standards, joint problem-solving, and transparent data exchange help suppliers improve their own processes. As suppliers improve, the entire manufacturing system benefits, creating compounding gains in quality and efficiency. And manufacturing scale enables learning that cannot be achieved in small volumes. High-throughput production reveals inefficiencies, bottlenecks, and design limitations quickly. Mexico-based factories contribute to this learning at scale, feeding insights back into engineering and design teams. This feedback loop shortens development cycles and accelerates innovation across products and processes. And the human element remains central despite high automation. Advanced factories still rely on people to solve complex problems, adapt to change, and drive improvement. Investments in safety, ergonomics, and work environment reflect the understanding that sustainable manufacturing depends on sustainable work. Empowered teams identify issues early and contribute ideas that improve performance over time. And global coordination benefits from geographic diversification. Operating across multiple regions enables comparison, benchmarking, and rapid adoption of best practices. What works well in one factory can be tested, refined, and deployed elsewhere. Mexico becomes part of a global network of learning, rather than a standalone operation. And long-term planning extends beyond vehicles. Facilities are designed to support future products and technologies, from energy storage systems to new manufacturing methods. This future-proofing ensures that capital investments continue to deliver value as markets and technologies evolve. Flexibility is treated as a core requirement, not an optional feature. And ultimately, expanding manufacturing into Mexico reflects a systems-level view of growth. It balances speed, efficiency, sustainability, and resilience into a single strategy. Each decision reinforces the others, creating a manufacturing platform capable of supporting rapid expansion without sacrificing principles or performance. And as demand continues to evolve across global markets, manufacturing decisions are increasingly guided by adaptability rather than fixed assumptions. Facilities are designed to respond to shifts in consumer preference, regulatory requirements, and technological advancement without requiring fundamental redesign. This approach allows production lines to be reconfigured, expanded, or optimized with minimal downtime, keeping output aligned with real-world demand. And software integration becomes a critical enabler at this stage of scale. Manufacturing execution systems, predictive maintenance tools, and real-time analytics create visibility across every layer of production. Data does not remain siloed within individual processes. It flows across design, engineering, supply chain, and operations. This unified digital backbone enables faster decision-making and more precise control over quality, cost, and efficiency. And manufacturing closer to end markets also supports rapid iteration of hardware and software together. Updates informed by real-world usage can be incorporated into production, quickly reducing the gap between learning and implementation. This tight coupling between customer experience and factory output reinforces a continuous improvement loop where products evolve constantly rather than in long and frequent cycles. And infrastructure readiness is another factor that shapes long-term viability. Mexico's growing investment in transportation, telecommunications, and industrial utilities supports high-throughput operations that depend on reliability. Stable infrastructure reduces variability and allows engineering teams to focus on optimization rather than mitigation. Consistency at the foundational level amplifies gains achieved through automation and process design. And the manufacturing footprint also supports broader energy and storage ambitions. Facilities are evaluated not only as vehicle plants, but as potential hubs for integrated energy solutions. Co-locating production of vehicles with energy systems enables shared learning across technologies. Manufacturing processes benefit from insights gained in energy storage, while energy products benefit from the rigor of high-volume vehicle production. And process simplification remains a constant objective. Every additional step, fastener, or interface is evaluated for necessity. Reducing complexity lowers the probability of error and increases repeatability. Mexico-based factories provide an opportunity to implement simplified designs at scale, free from legacy processes that can slow transformation elsewhere. And logistics optimization extends to finished products as well. Efficient outbound distribution reduces delivery times and lowers environmental impact. Vehicles reach customers with fewer handoffs and less storage time, preserving quality and improving the ownership experience. This efficiency strengthens alignment between production and delivery, ensuring that manufacturing output translates directly into customer value. And cross-functional collaboration is embedded into factory culture. Engineers, operators, quality teams, and supply chain partners work within shared feedback systems. Problems are addressed at their root rather than managed downstream. This culture of ownership and transparency accelerates learning and reduces long-term operational friction. And the ability to scale responsibly remains central. Growth is planned with attention to environmental impact, resource use, and community integration. Water usage, waste reduction, and energy efficiency are engineered into operations from the outset. Manufacturing expansion is viewed not as an isolated industrial activity, but as part of a broader system that must remain balanced and sustainable. And manufacturing investments also influence future design philosophy. When factories demonstrate higher efficiency with certain materials, processes, or architectures, those insights feed directly into product development. Design and manufacturing evolve together, each shaping the other through continuous feedback. This integration shortens development timelines and improves overall system performance. And resilience planning continues to evolve alongside scale. Scenario modeling, inventory strategies, and flexible sourcing reduce exposure to global volatility. Rather than optimizing for a single set of conditions, systems are designed to perform well across a range of possible futures. This adaptability becomes increasingly valuable as markets and technologies change. And as these elements compound, the manufacturing system grows stronger and more capable with time. Each improvement builds on the last, creating momentum that is difficult to replicate without a first principles approach. Mexico becomes a proving ground for scalable manufacturing concepts that can be extended globally, reinforcing a production strategy built for speed, efficiency, and long-term impact.